Hello and welcome to this look at an acid-base titration question to find a molecular formula of a compound. It includes a slightly awkward scaling factor to consider, so I'll point that one out when it turns up. So this is our question. I started by just putting in the part of the question that includes the procedure that the student carried out. So we need to visualize that first so we have an idea in our head about what they did. So they took 2.6432 grams of compound A. If I just take my highlighter, and that's this part here. They diluted solution to 250 centimeters cubed in a volumetric flask. So that's these two stages here, and we're to this point. Then a student fills the burette with this solution. So that means some of this goes into this burette and fills it up. The student adds 25 centimeters cubed of 0.224 moles per decimeter cubed of KOH to a conical flask. This goes in here. Obviously that would be that reddish color once the end point is reached, because you're going from an alkali back to an acid. I'm assuming we're using something like litmus or universal indicator perhaps. Okay. So it says 31.25 centimeters cubed of compound A was required to reach the endpoint. So now we've had to think about what's actually going on, we can proceed to the calculation itself. Now the remainder of the question says the formula of compound A can be simplified to H2X, and the equation of the titration is as follows, and you can see it on the screen. The first thing they want you to do is calculate the amount in moles of compound A used in the titration. So I use the data moles equation moles answer method. So what I do is I look for the thing that has the information that allows me to work out its moles. And that's obviously the volume and the concentration of potassium hydroxide. So I list that in my calculation. Then I just do N equals CV, and that gives me 5.6 times 10 to the minus 3 moles. Now looking at the equation, the mole ratio or stoichiometry between H2X and KOH is 1 to 2. So therefore the number of moles of H2X is going to be half that of KOH, which gives me 2.8 times 10 to the minus 3 moles, which is the first part of the question answered. Part B wants me to calculate the molar mass of compound A. So I know that 2.8 times 10 to the minus 3 moles is the moles of compound A in my 31.25 centimeters cubed. I need to scale this back up, because I need to be able to use this value, 2.6432 grams, because of the connection between moles mass and molar mass. So my scaling factor is my 250 over 31.25, because that tells me how much to multiply it up by. So remembering the visualization from earlier, we had 250 centimeters cubed in which our 2.6432 grams had been dissolved. Only 31.25 of that reacted, and that contains 2.8 times 10 to the minus 3 moles. So this number of moles has to be multiplied up by however many times 31.25 goes into 250. And that's what we call the scaling factor. So now we know the number of moles in compound A in 2.6432 grams. We can work out the MR really easily, which gives us a nice clean number of 118 grams per mole. Then they give us the percentage composition by mass of compound A. And they want us to work out the empirical and molecular formulae of compound A. So starting with the empirical formula, you divide the percentage by the relative atomic mass of the element concerned. And that gives us this ratio. Now obviously dividing by the smallest number, which is 3.39, gives us 1 to 1.49 to 1. So we're still not quite out of the woods yet, because we're looking for whole numbers. So you multiply those those numbers you've got up by 2 to get rid of the decimal and the ratio, in other words 1.49. And that gives us C2H3O2, which has a mass of 59 grams per mole, or the molar mass, 59 grams per mole. So going back to our 118 grams per mole that we worked out a moment ago, That's obviously twice 59. So the molecular formula must be the empirical formula doubled, which is C4H6O4. Okay, hopefully this has been a useful look at this part question. And until next time, thanks for listening and see you soon.